Welcome to this explainer. Today, we're diving into something absolutely crucial for anyone in modern software delivery, and that's securing your CI/CD pipelines against credential leaks. If you're building and shipping code, you're dealing with secrets. We're talking API keys, database passwords, cloud access tokens. And as our delivery pipelines get faster and more automated, the risk of those secrets sprawling out of control and falling into the wrong hands, well, it's never been higher.
To really wrap our heads around the scale of this, think about this number, 12 million. According to GitGuardian's 2025 State of Secrets Sprawl report, that's 12 million new secrets detected in public GitHub commits in just 1 year. That is a mind-blowing amount of exposed credentials, and every single one of those represents a potential direct path straight into an organization's production systems.
And the fallout, it can be absolutely devastating. Literally, a single leaked AWS key can rack up tens of thousands of dollars in a matter of minutes. Now, I want to be super clear here. This isn't happening because developers are careless. Not at all. It's just that modern software delivery is a complex beast, involving dozens of config files, environment variables, and integration points. It is incredibly easy for a secret to accidentally slip through the cracks.
Okay, let's dive right into this. Today we're going to cover the secret sprawl crisis, TruffleHog as the verification solution, the 5 layers of defense, CI/CD pipeline integration, and finally, triaging false positives.
Starting with Section 1, the secret sprawl crisis. The reality is, without strict guardrails, your environments will just happily stage and commit whatever you tell them to right into version control. Git simply doesn't know the difference between a random text string and your most critical production database password.
Because of that blind spot, secrets end up hiding in plain sight all over our code bases. It's kind of like a giant puzzle where pieces just get lost. You might have a local .env file packed with database credentials that accidentally get staged, or actually scratch that. How about a Python script with a hard-coded AWS key from a quick local test? We see YAML configs with connection strings, Docker files putting API keys right out there in their env instructions. It's just so easy for a single key to travel from a developer's laptop straight into a public leak.
Moving to Section 2, TruffleHog, the verification solution. This brings us to a tool that tackles this problem with, honestly, a fantastic superpower. While a lot of tools can scan for strings that look like secrets using regular expressions, TruffleHog goes a massive step further.
Now, you might be wondering what actually makes a secret verified. Well, TruffleHog doesn't just say, hey, this kind of looks like an AWS key. No, it actually takes that credential, tests it against the provider's API, and confirms if it's currently active and live. So when you use the -- only verified flag, it's a real game changer. It dramatically cuts down pipeline noise because you're only getting alerted about secrets that pose a real immediate threat.
To put that into perspective, let's compare TruffleHog with another really awesome tool, GitLeaks. Now, GitLeaks relies on rejects and entropy, meaning it doesn't verify the secrets. That makes it lightning fast, but it can throw a moderate amount of false positives. TruffleHog, on the other hand, adds that active API verification layer. It's a bit slower because of that, but it drives the false positive rate incredibly low. So the smart play here? Use GitLeaks for those super fast pre-commit checks on a local machine, and bring in TruffleHog for the deep scans and rigorous pipeline verification.
All right, Section 3, the 5 layers of defense. Relying on just a single checkpoint is never going to be enough. For instance, just depending on local pre-commit hooks is pretty risky because a developer can easily bypass them with a simple -- no verify flag. We absolutely need defense in depth.
So what does a robust, multi-layered strategy actually look like? Well, Layer 1 is pre-commit scanning, catching the secret before it even hits the Git history. Layer 2 is in-pipeline PR scanning, which is a server-side check that simply cannot be skipped. Layer 3 is push protection. Think of GitHub's automated platform-level defense that blocks recognized secret patterns right out of the gate. Then, Layer 4 is post-merge and runtime scanning to catch anything that might have slipped through. And finally, Layer 5, periodic deep repository scans using TruffleHog to audit your entire history.
So the crucial point is that this creates an interlocking system. A leaked credential would literally need to bypass all 5 of these distinct layers to go undetected. No way is that happening easily. By combining real-time pull request scanning with, say, a weekly full repository scan, you're getting truly comprehensive coverage.
Moving right along to Section 4, CI/CD pipeline integration. Now we get to the implementation phase. Integrating tools like TruffleHog into your pipelines is a must, but you have to be smart about it.
Because if you slow down the build process, you're going to frustrate developers and cause a lot of friction. To keep pipelines blazing fast, we use an efficiency workflow, similar to how it's mapped out in Azure Pipelines. First, you query the API to count the exact number of commits in the pull request. Second, you execute what's called a shallow fetch based on that count. And third, you run TruffleHog only on that difference rather than the whole shebang.
And this brilliantly illustrates how we cater to the developer's need for speed. Shallow fetching limits the Git history cloned to your CI/CD runner to literally only the relevant commits. Instead of downloading years of Git history and scanning it every single time a PR is opened, you're just grabbing a tiny targeted snapshot and scanning it in seconds. It's so much more efficient.
When you're actually running TruffleHog in your pipeline, using a Docker container is definitely the way to go. You'll want to use these essential flags: --rm to clean up the container after the run, -v to mount your cloned repository, --only verified to ensure you're only failing builds on active threats, and most importantly, the --fail flag. That flag's the real enforcer. It exits the program with a non-zero status code, breaking the build and ensuring absolutely no PR with a live secret gets merged.
Finally, Section 5. Triaging false positives. Look, even with top-tier verification, you're going to encounter alerts that need human review. It's just part of the process.
But let's tackle developer frustration head-on and frame this as a logical workflow, not a massive roadblock. First, why would TruffleHog verify a credential that isn't actually a breach? Well, it could be test fixtures or mock data using strings structured exactly like real keys. It might be a public demo key copied straight from vendor docs, or, and this is kind of cool, it could be a security decoy, like a canary token, intentionally planted by your security team to look completely live. Or, it might just be a stale credential that was rotated months ago but never officially revoked.
Let's move to the next step and see how this builds a really calm, step-by-step triage workflow. When an alert fires, 1. Identify the file and line number. 2. Check the detector type. Are we talking about an AWS key or a Slack token? 3. Look at the surrounding code context. Like, is it obviously a test file? 4. If you can, check the actual service dashboard to see what permissions that key holds. And 5. Make a definitive decision to either rotate the key or exclude it.
To keep that pipeline noise to an absolute minimum, employ these best practices. Use a .trufflehog ignore file to permanently exclude known test paths. Filter your scans to only look for detector types that actually match your tech stack. Crucially, never just globally ignore verified findings without digging in first. And lastly, if a credential status is even a little bit ambiguous, for sure, just rotate it. The minimal cost of taking 5 minutes to rotate a key is always better than ignoring a real leak.
So we've covered the sprawl crisis, the power of verification, and how to build a layered defense. As we wrap up this explainer, I want to leave you with this provocative question to take back to your own teams. If a developer accidentally committed a highly privileged secret today, right now, how many layers of defense would it have to bypass to make it into production? Think about that and start building those layers. Thanks so much for joining me, and I'll catch you next time.